chapter 7 video on sample proportions. A bit of a long time coming, but I am doing it now. Yeah, and I chose my topic to be sample proportions. I'm not going to be doing the problem, but I will be showing you some prerequisites of what you need to know before you do the problem, right? So you're going to need to know the formula to find the mean and standard deviation. For the mean, it should be pretty simple, right? Oops, that's too small. The mean of the sample proportion is the mean for the population, equals to the mean for population. It's not too hard. The standard deviation for the proportion is where it gets a little bit trickier and where your memorization skills might be put to the test. It's here, standard deviation of the sample proportion equals to the square root of probability P times 1 minus P, right, over the amount of trials you have, right? You can see that right there. So there are two big formulas you're going to need to get. And then another formula you're going to need to know is how to find the probabilities of certain different percentiles of our standard, our normal distribution chart, I guess I would say. Right, and in order to find that, right, in order to find a different kind of probability, you put Z, that's for Z score, right, and this could be just about any inequality depending on what the problem asks for you, and then it would be the percentage, right, of the whatever the problem is asking you for, minus the percentage that you got, which is, it should be the mean, right, the sample proportion mean, over the standard deviation, right? And so the standard deviation formula is kind of a prerequisite to this one, right? And now that everything is on here, we should get right into the problem. So the problem says, power companies severely trim trees growing near their lines to avoid power failure due to falling limbs in storms. Applying a chemical to slow the growth of trees is cheaper than trimming, but the chemical kills some of the trees. Suppose that one such chemical would kill 20% of sycamore trees. The power company tests the chemical on 250 sycamores. Consider these an SRS of the population of all sycamore trees. It's going to ask you for the standard deviation of the proportion of trees killed in the sample, right? And which is a trial, 250. And then the next question is going to ask you calculate the probability that at least 60, which is 24% of the sample, is killed. Now on to Tien.
Alright, now that we've established the mean and standard deviation of our sample, part B gives us a 60 trees are to be killed, or a 24% are to be killed. And we're looking for the probability that 24% is going to be killed. Now that we have a 24% mean, a standard deviation, this is a prime candidate for a Z-score. However, before that, we need to prove that this is going to be a normal distribution, and we can do that with the central limit here. That basically states that our sample size times the proportion needs to be greater than 10, and that our sample size minus 1 minus the proportion needs to also be greater than 10, which it is. Just trust me. Now that we know this is a normal distribution, we need to find the probability that more than 24 are killed. So to do that, we're going to need a Z-score. Our Z-score needs to be greater than or equal to 24% minus 20% divided by our standard deviation, which is 0.0253. And that equals 1.58. With that 1.58, we're now going to look for the probability, and you can use this using a calculator, table A, or any means of your choice really. P of Z greater than or equal to 1.58 And if you use table A or a calculator, that should round to 0.571. Wait. Now then, as always, as any good statistician, you need to take this number and write it into a sentence. The probability that 60 trees, or 24% of our sample, is killed is equal to 0.0571, or a 5.71% chance.
And